Good afternoon. So in this I will explain the concept of critical path method. So there are two important mathematical models were developed in the field of project management to achieve the objectives of project management. So the two mathematical models are critical path method and project evaluation review technique. So critical path method or critical path is the longest path in the network which will determine the possible project duration by the effective utilization of all the limited resources. And that critical path mathematically calculated by combining all the critical activities based on the information given for the project. Then what is the meaning of critical activity, sir? So a critical, we might have more number of activities in the project, but there some activities are called as critical activities, where the activities can be finished within the time, or simply we say that the activities which cannot be delayed are said to be critical activities. So this can be obtained by, or what I mean to say is critical activities can be obtained or calculated by the concept of slack, and that slack is defined as the difference between the earliest start and latest finish. So whenever we are dealing with a project based on the given information, we are going to calculate earliest starting times and latest finishing times, and we take the differences between those two activities. Now all this I will explain with an example. See, this is an example of a project, and is asking us to calculate the critical path and project duration for the data given here. So here 6 activities were given, and for all the six activities corresponding required durations are given. So remember, whenever we are dealing with CPM and PERT, the first step is to draw the network diagram. So I'm going to draw the network diagram. I have already told you that network diagram can be drawn by using activities with corresponding durations. So here if you see the first activity, this is from 1 to 2 and second is 1 to 3, and this means both the activities are starting from 1. So let's take 1, and 1 is with 2 and 1 is connected with 3. This means from 1 we need to take two different activities called 1 to 2 and 1 to 3, and its available durations are 13 and 12. And next is 2 to 4, and this is 2, and let's say this is 4, this is 2 to 4, available time is 2. And next is 3 to 4, this is 3 and this is 4. Let's connect these two with this 3 to 4 with an arrow, and the available duration is 8. And next is 3 to 5, and this is 3, and 3 to 5, 3 is starting point, so this is 3, and its ending point is 5. Let's say this is 5. So 3 to 5 available duration is 15. Next is 4 to 5, this is 4 and this is 5. 4 to 5, and duration is 2. So this is the network diagram. Now to find out critical path, we need to find out critical activities. So to find out critical activities, we have to calculate earliest times and latest times. So I'm calculating for earliest times. So I'm calculating here the earliest times. So earliest times are representing by earliest times are representing by E. Earliest start na, so starting is always representing with I, finishing is representing by J. So earliest start, so we have to represent with EI. Okay, now in this network we have 1 2 3 4 5 connected. So we are going to calculate 5 earliest times. So first one is E1. So this is E1, this is called E1. So as we know that the starting point of any project is equivalent to 0, and next is E2. So E2 is, this is E2. So if you observe carefully, to reach 2 we need to start from 1 and we need to cover this duration. So this means E2 can be obtained by E1 plus duration from 1 to 2. That implies E1 means 0 plus duration from 1 to 2 is 13. So 0 plus 13 is equal to 13. Similarly, E3. E3 is nothing but, this is 3 na, so to reach 3 we need to start from 1 and we need to cover this duration. So this can be calculated by E1 plus duration from 1 to 3. So this is 0 plus 12 is equivalent to 12. Now coming to 4, E4. If you see 4, this is 4. Now if you observe carefully, to reach 4 we have two directions, one is from 2 and another is from 3. So whenever we have two directions like this, then we have to take the maximum possibility. So we have to take maximum of, to reach 4 we can start from 2. This is E2 plus duration from 2 to 4, and another path is 3 2. That means E3 plus duration from 3 to 4. So let's simplify this. Maximum of E2 means 13 plus 2 to 4. 2 to 4 is 2. Similarly, E3 means 12 plus 3 to 4 means 8. So this implies maximum of 13 plus 2, it is 13 plus 2. 13 plus 2 is equivalent to 15. 12 plus 8, 20. So from this, maximum means 20 is the maximum. Coming to the 5, E5. E5 we can reach, again to reach 5 we have two paths. One is from 4, another is from 3. So we can write maximum of E3. E3 plus duration from 3 to 5. Next is E4. E4 plus duration from 4 to 5. This implies maximum of E3 means 12 plus 3 to 5, 15. E4 means 20 plus 4 to 5, it is 2. So this is nothing but maximum of 12 plus 15, 27, and 20 plus 2, 22. Out of these, the maximum is 27. Okay, so we have got all the earliest times. So let's place earliest times like this. So this is E1 na? So E1 is equal to 0 and E2 is equivalent to 13. Here E2 is equivalent to 13. Similarly, E3 is equal to 12. E3 is equal to 12. Next is E4. E4 is equivalent to 20. And last, E5 is equal to 27. So these are the earliest times. Similarly, we have to find out latest times. Now I will explain how to find out latest times. Now the latest times representing by Lj can be calculated in reverse process. That means, did you remember in earliest times we started with 1, finished by 5. Now in the latest times we start with 5, ends by 1. So now We start with L5. So L5 is now L5 is not 0. L5 is the last activity of the project. Therefore, this L5 is equivalent to E5, that is equivalent to 27, because we have got E5 is equal to 27. Now we move with L4. Now to find out L4 in this diagram, you can check in the reverse process. See, 4 we can reach from only 5. Do remember, we have to see only in reverse direction. So 4 we can reach from 5. So this can be written as L5 minus duration from 5 to 4. This implies L5 means 27 minus duration from 5 to 4 means 2. So 27 minus 2 is equal to 25. Similarly, L3. Let's take 3. If you see these 3 we can reach by two paths. One is from 4, another is from 5. So now we are doing in reverse process. So we have to take minimum of L4 minus duration from 4 to 3, and another is L5 minus duration from 5 to 3. This implies minimum of, what is L4? L4 is equivalent to 25 minus 4 to 3 means 8. Similarly, L5 means 27 minus 5 to 3 it is 15. So this implies minimum of 25 minus 18 is 17, 27 minus 15 is 12. So if you observe, the minimum of these two is, minimum of 17 comma 12 is 12. Now coming to L2. So L2 we can reach from only L4. So this is L4 minus duration from 4 to 2. This implies L4 means 25 minus duration from 4 to 2 is 2 is equivalent to 23. Now coming to the last one, L1. L1 if you observe, this is L1. L1 we can reach from 2 as well as 3. So therefore, again we need to take minimum. This can be L3 minus duration from 3 to 1, L2 minus duration from 2 to 1. This implies minimum of L3 means 12 minus duration from 3 to 1 it is 12, L2 means 23 minus duration from 2 to 1 it is 13. So this is equivalent to minimum of 12 minus 12 which is 0, and this is 10. Out of this remaining least is 0. So now this L1, L2, L3, L4, L5, let's substitute in the diagram. So L1 is 0, L2 23, L1 is 0. See here L1 is 0, and here it is L2. L2 is equivalent to L2 23, L3 is equivalent to 12. Okay, L3 12, L4 25, L4 25, and L5 27. Okay, now if you see carefully, now we have got E1, L1, E2 L2, E3 L3, and E4 L4, finally E5 L5. So for all the 5 activities we have obtained earliest times and latest times. Now we need to find out the differences between all these earliest times and latest times to find out the critical activities. Now tell me, which activity is having 0 float? Here the float is nothing but the difference between earliest times and latest times. So E1 minus L1 is 0. So this is called one critical activity. C means critical activity. So this is E2 minus L2 is not critical. E4 L4, it's not, difference is not 0, but here it is E3 minus L3, here difference is 0, so it is critical activity. And coming to the last one, it is difference is not 0, so critical activities are, so from the above diagram or from the above calculations we can say that L1 minus E1 is equal to 0, therefore it's a critical activity because this 0 is representing float. So wherever you have float is equal to 0, that means that that particular activity requires that particular activity having zero delay. Zero delay means that activity can be finished within the time. But if you take the second one, we have got the difference as 10. This means that this activity require 10 additional days. But if you see the third one, difference is 0, therefore this is called critical activity. And the last one, this is not critical activity, this is not critical, this is critical because we have got 0. So this one, what is the first one? First one is 1. So 1, this is 1, this is activity 1, this is activity 3, this is activity 5. So for all these 3 activities we have got the slacks as 0. So therefore critical path is 1 to 3 and 3 to 5. So at 1 we got 0, for 3 at 3 we got 0, and at 5 we got difference is 0, therefore critical path is 1, 3, 5. Now let's find out its durations. So for 1 to 3, what is the duration? 12. For 3 to 5 it is 15. This is 12, this is 12, and this is 15. Therefore project duration is equivalent to 12 plus 15 is equivalent to 27. That's it. Thank you very much.